The first thing you may see when you open the complex numbers calculator is this security warning that says macros have been disabled. The calculator is heavily based on macros, and macros need to be enabled in order to have the functionality the calculator offers. So enable the content. Depending on your screen resolution, the calculator may seem to be too small. I would recommend the next thing you do is to stretch the calculator across your screen. In order to do that, you need to click the zoom button. This will make the calculator as large as possible on your screen. At this stage, you may save the file so it remembers these settings for the next time. I recommend that in the future when you exit the calculator, you never save it, and then the calculator will retain this default look and the values. Now let's quickly review what the complex numbers are. Basically, complex numbers are numbers that consist of two numbers. Or we like to say that complex numbers have two components. Now, there are also two different forms that you can express complex numbers in. One is called rectangular form, and the other one is called polar form. Each of the two forms will have two components. If we decide to express complex number in a rectangular form, the two components will be real and imaginary components. If we decide to express complex number in a polar form, then the two components will be magnitude and angle. In this calculator, on the left-hand side, you have complex number 1, or complex number Z1. On the right-hand side, you have complex number 2, or Z2. Both of these complex numbers have the upper fields that reflect rectangular form with its real and imaginary components. The bottom fields reflect polar form with magnitude and angle. In between, you can select the operation you want to perform over those two complex numbers. The result will be displayed on the far right-hand side. Also, result will be displayed in its rectangular form and the polar form. For any of these fields that represent complex numbers, the rectangular form and the polar form are related to each other. Thus, if you make changes on one side, the numbers on the other side will change as well. For example, complex number 1 in this case has real component 3 and 0 imaginary component, which corresponds to magnitude 3 and angle 0. If I change imaginary component to, let's say, 3, then the magnitude will change correspondingly and the angle will be calculated. Note that angles in this calculator are always expressed in degrees, not radians. Similarly, if I change the magnitude to, let's say, 5, the real and imaginary components will be calculated that correspond to that magnitude and angle that was there before. So, in a rectangular form, we can say that complex number Z1 is expressed as R1 plus JX1. Similarly, Z2 is expressed as R2 plus JX2. If we were to express these numbers in a polar form, we would have them as Z1 is magnitude of Z1 at the angle of θ1, and Z2 is magnitude of Z2 at the angle θ2. If you use calculator to perform conversions, the calculator will use these equations. So when you convert rectangular to the polar form, calculator will calculate complex numbers magnitude and an angle. If you convert from polar to rectangular form, calculator will calculate its real and imaginary component. So in this case, when I change the magnitude, real and imaginary components were calculated. I can also decide to change the angle, and components will be recalculated again. If I change real component, magnitude and angle will be recalculated. As you can see, if I change any of these four fields, the calculator will perform corresponding calculations in order to make the two forms match each other. We can say that this complex numbers calculator can perform rectangular to polar form conversions and polar to rectangular form conversions. Sometimes that may be all you need. You can use complex number Z1 to perform those conversions, or you can use complex number Z2. it will do the same. Now, I haven't yet mentioned memory fields, but the same holds for memory fields. If you change any of the components in any of these three memory fields, the conversion will be calculated automatically. Okay, so let's use some round numbers for our complex number 1. Let's say 3 and 4 as the two rectangular components. And we can use maybe 2 and 2 for complex number Z2. So let's have a look at the operations now. By default, addition is selected. Now any calculator can perform the four basic mathematical operations: addition, subtraction, multiplication, and division. So if I want to add these two complex numbers, the result will be shown. Real component of result equals to the sum of the real components of the two numbers. Similarly goes for imaginary component, in this case 6, will equal 4 plus 2. Corresponding polar forms of all the complex numbers will be calculated at the same time. If I want to subtract Z2 from Z1, I can change operation to subtraction. The result will be immediately calculated. I can change to multiplication. If I use multiplication, the calculator will actually use magnitudes to multiply them to calculate the magnitude of the result, and will also add up the angles to calculate the resultant angle. In this case, as you can see, the angle is larger than 90 degrees, which results in a real component to be negative. By the way, any complex number can have positive or negative real and imaginary components. Magnitude is normally always positive, and then the corresponding angle would be between the range of minus 180 to plus 180 degrees. When it comes to division, if I have 0, for example, as my number, the result will be infinite, and the angle will be angle of my complex number Z1. Okay, so let's go back to default values. Obviously, in this case, there is no imaginary component, so 3 divided by 6 is 0.5. Now, those were the four basic mathematical operations. However, this complex numbers calculator can also handle parallel connection of two impedances Z1 and Z2. So this calculator is specifically designed for electrical engineers. If we have, in this case, two resistors of 3 and 6 ohms connected in parallel, the equivalent resistance will be 2 ohms. The calculator uses equation Z1 times Z2 divided by Z1 plus Z2 to calculate the equivalent resistance or equivalent impedance. I can have impedance 3 plus 3 ohms, I can have impedance 6 minus 5 ohms, and their parallel connection will have equivalent impedance of 3 point something plus J 1 point something ohms. Let's say I need this result for further calculations, and because it has so many decimal figures, it is hard to remember or even write it down. That is the reason I developed memories in this complex numbers calculator. So depending on which memory we want to store this result in, we can click one of these three buttons. Let's say we want to save result to memory 1. There it is. Let's say we calculated some other equivalent impedance, and we want to save this result in memory number 2. And say these two equivalent impedances are connected in series, so we want to add them up. The calculator now allows us to retrieve the memory 1 and fill in the complex number Z1 from the memory 1. We can use complex numbers stored in memory 2 to retrieve it and fill the complex number 2 with memory 2. And we can change the operation to addition, which corresponds to series connection of these two equivalent impedances. And finally, we have the result. And as always, the result is conveniently given both in rectangular and the polar form. So you see that beneath both of these complex numbers, Z1 and Z2, we have 3 buttons. The reason is because we have 3 memories. So we can choose which memory we're going to use to fill in the complex number Z1. We can use memory 1, or 2, or 3. For complex number Z2, We can also use memory 1 or 2 or 3. Feel free to change any of the fields for complex number set 1, set 2, or any of the 3 memories. However, if you attempt to change the field that belongs to a result, the calculator will tell you that you cannot change result fields directly. So don't do it. Also, every other field in this calculator is protected so it doesn't get erroneously deleted or changed. In general case, complex numbers can have negative components. For example, -2 plus j minus 2, which is -2 minus j2. Or complex number 5 minus j4. If we perform addition, subtraction, multiplication, or division with these numbers, everything is fine. However, we cannot perform finding equivalent impedance of a parallel connection of impedances that have negative real components. Real component of an impedance corresponds to resistance, and resistance cannot be negative. Thus, if you have negative numbers in real components of your complex numbers and you want to perform parallel connection, the calculator will automatically correct negative resistances and change them into positive numbers, so then the calculation can be performed. So the complex number with the negative real component doesn't make sense in electrical engineering if it describes an impedance. When you're done with all your complex numbers calculations, simply close the Excel spreadsheet and don't save it so it can retain its default values and the look. So if I open the calculator again, it will show me the previously saved state. Remember, if at any time you destroyed some of the values or functionality of this calculator, feel free to go to wsasha.com/CNC and download the latest version of my complex numbers calculator.